Hi, this is Charles Maggio. Welcome back to R for Epidemiology. In this screencast, I want to introduce the concept of a list, which is an R object that is different from a vector, a matrix, or an array in that it's allowed to contain unlike elements. And by this, what I mean is that in an array or a matrix or a vector, every single element has to be of the same kind. It has to be all numerical, character, or logical. If there is one single different element within any one of those three objects, R will coerce it to the least informative type of element. A list, by contrast, is allowed to contain different kinds of elements. And let's talk a little bit about what you would go through to create a list. And I want to talk a little bit about how to index a list. To be perfectly honest, I don't use lists very frequently in terms of creating primary epidemiologic objects or doing analyses, but lists are extraordinarily important in R for two reasons. First, a list is essentially the basis for a data frame, and a data frame is a very useful and fundamental epidemiologic object in R. Second, many function results are returned to you as lists. So being able to negotiate lists and index them and know what they are and work with them becomes really actually quite important. So let's take a look at how we would create a list, and I can do that by just bringing up a little code that I've already written to save a little time. And what I'm doing here first is I'm going to create three separate objects in R. First, I'm going to create a numeric vector called X. Then I'm going to create a character matrix called Y. And finally, I'm going to create a character vector called Z. Now, I could bring any of these up at any time I want. So if we want to see what X looks like, it looks like this. Want to see what Y looks like, or see what Z looks like. And here are our three objects that we created. A list, using the list function in this case, allows us to combine these three objects into a single object, and that I'm going to call MM. And let's just do that. And now there's an object that exists called MM, and I've combined the three previous objects, a numeric vector, a character matrix, and a character vector into a single object called MM, which looks like this. Now, here, basically, I've asked for MM, and now it's being returned to me. Notice something about the indexing. There is a double bracket now, and then for the vector, a single bracket followed by a single bracket, and then each element of that vector. Then there is another double bracket with the number 2 in it, and then the by now somewhat familiar indexing for matrix, meaning row, column, and then finally another double bracket with the number 3 in it, and then another single dimensional indexing bracket here. So really what that does is it tells us how to index lists. And here's a way to sort of think about it. Before we actually go into it, let me just give you an idea of how you can kind of think about it. Think of a list as three sort of like, separate, of this particular list that we created, as three separate bins. Here is our list called MM. And within that list, we have X, which is our numeric vector. We have Y, which is our character matrix. And we have Z, which is our character vector. In R, when you're indexing a list, you could think of each of these bins as being indexed by a double bracket. And let's index this one just to complete the thing. This is actually a bracket. I don't do a great job of that, but here we go, right? So here is another bracket. And this is the first bin, the second bin, and the third bin. And then within each bin, you can actually index the contents of that bin with a single bracket following it. Now, in this case, right, there's just a single number here. And this is a one-dimensional one, so there's a single number there. Here, it's row and column again. So if you're going to index a list, the way I recommend that you index it is with a double bracket followed by a single bracket. That's worked for me. I'm going to talk in a moment about some of the some of the reasons why you may want to use other indexing approaches. But for right now, let's just take a look at that approach. So if I were to want to index out the letter D, what I've done here is I've put the second bin, or the second main element of the list here, 2. I put this 2 right here, essentially. And then I followed it by our usual, or the type of matrix indexing that I've already introduced, row column notation, which would be second row, second column right here. And if I submit that, what I get is the letter D. So it is the second main element and the second row, second column of that element. If I wanted the name Mary, I would index the third bin and the third element of that bin right there, Mary. Why would you or wouldn't you want to use? There are other ways actually of indexing lists, and I'm going to bring this over here right now. There's a nice answer on Stack Overflow. All you need to do is actually Google this. What's the difference between this and this notation for accessing elements? There are different ways of doing it. And the 2 first answers that come up are actually kind of informative. And what they basically come down to is that depending on how you actually index the element within the list, you will get different kinds of objects returned. So if you need to save these particular elements in one way or another, then you may need to revisit this. I can tell you that in my experience, it has rarely been the case that I've had to do anything other than this kind of indexing. It works relatively well for me. I've not come across too many errors, or actually any errors in that case. But in any event, that's a list. And as I said, very useful to access the results of other functions, and also very useful for our future discussion of data frames.